Okay, Bismillah. So today we're going to be learning on how to calculate solubility using ice tables. So before I start, I want to say that I'm not a tutor, I'm not a teacher. I like to study by teaching others. And this will be beneficial not only to you guys, but myself as well. Okay, with that being said, the way I like to uh, learn chemistry is I like to learn how to do the problems itself and not necessarily the minor details, because chemistry is a calculative, qualitative subject, and there's a lot of information that I believe is not relevant to the exam that students stress about, and they miss the part where they have to calculate stuff. And so I like to learn the calculative aspect of things because 95% of the exam is calculative. And if you don't know how to calculate something, the chances of you doing well on the exam diminishes. So we're going to be learning about how to calculate solubility using ice tables, and the three cases that we will see um, ice tables and solubility. So what is solubility? Solubility is a concentration, and it depends on some conditions like pH and ions. And it must contain a solid. If there is no solid in the equation, then you cannot obtain solubility. And your answers will be in molarity because obviously it's concentration. Now, sorry. Using ice tables, we will solve solubility in three instances. Number one, solid in just water. This is your basic ice table. And two, solid in salt water. And three, solid when pH is given. All of them require ice tables. They all have the same a way of solving things, just a little slightly different. Also, salt in salt water is also part of solubility with common ions, which we will talk about in a different video. All right, let's start off with doing some questions. Solubility in pure water, your basic solubility ice table question. Calculate the solubility of lead chloride in pure water at 25 degrees Celsius, given that the constant is 1.7 times 10 to the power negative 7. Okay, so let's start off with just writing the equation. Let me do a different color. I like it. Okay, so here we have your lead chloride, and this is in the solid phase. The matters do matter. The state of the elements, the compounds do matter. And so this, I don't like that arrow, will become TB. I don't know if it's, I think, yeah, this is, I believe, 2 plus aqueous plus 2Cl minus aqueous. Okay, so this is our equation. Now we need to make an ice table, and we need to calculate the solubility. Right, so we have some sort of um, lead chloride. We don't know how much, it really doesn't matter to our equation. So I'm gonna use a different color. I'm gonna put like some value. It does exist. We just don't care about it. There is some change of some value, and we don't really care about the solid because we don't solve for solids. Now, we start off with, let's see what color I should use. We could use, sorry, I'm really big with colors. Let's use a different color. Let's use maybe this. Okay. We started with zero uh, lead and zero chloride. We gained some lead and we gained some chloride. And this, for chloride, is 2 because the coefficient right here is 2. The coefficients matter. Now we solve for x. So we're gonna have let's do it here. So we're gonna have x, 2x squared is equal to I don't like that equal. 1.7 times 10 to the power of -5. Okay, now the rule of the exponent, the two exponent here is applied to the 2 here and the x. So you're gonna have 4x squared. I'm gonna reverse it, times x is equal to 1.7 times 10 to the power -7. Now you're gonna have 4x cubed. All right. I think I should have a little bit of room. I think I made too much. I write a little too big. Let's see if I can move this. Let me see if I could move this. 1 second. How do I select? Hmm. Sorry. I'm trying to figure it out. How could I move that? Edit? Yeah. Let me just move this down here. Oops. Okay. Now we solve for x. We're gonna do the cube root. I'm just gonna go straight into it. X is equal to 1.7 times 10 to the power -5 divided by 4. And you put this in your calculator, and you should get your solubility from there. Okay, it's gonna be 0.7 times 10 to the power -5 divided by 4. And you should get x is equal to 1 point, let's do 2 sig figs. 1.6 times 10 to the power of -2 molarity, because solubility is concentration. This is your basic solubility question in pure water. Let's check our answer using the answer key. 1.6, they did it, they solved it, so let's solve it as well. 0.016. 0.016. Yep. So your solubility is this in pure water. Now let's look at the next question. Let's move this if I can. Uh, yeah, let's move it here since we're not doing it anymore. Okay, let's bring this question back. Can I edit it? Yep. Okay. I should probably move that as well. Actually, no, I'm gonna keep it there. All right. Type solubility in salt water. I believe this is our second type of solubility question that we're gonna be looking at. Solid in salt water. Calculate the solubility of, again, lead chloride in a specific molarity of NaCl, which is a salt solution. Okay, given that the constant is 1.7 times 10 to the power -7. Let's start off by writing the reaction. So we have some breakup. Solid becomes Cb2 minus aqueous plus 2Cl aqueous with a negative charge. Okay, now this is our equation. We're gonna set up our ice tables. I, C, E, initial change equilibrium. So we start off with some solid, obviously, right? But again, it doesn't matter. We'll just put a digit sign right here. We start off with 0 lead. Now, how much chloride do we start with? We start off with 0.30 moles of NaCl. So that means chloride, we start off with 0.30 molarity of chloride because it's a salt. It's in a solution. It's in salty water. So there is some sort of chloride in this entire system. So we're going to have 0.30 molarity of chloride to begin with. And then we're going to have a change of solid. Again, it doesn't matter. we're gonna gain some lead, and we're also gonna gain fluoride to some digit. And then again, it's 2 because there's a coefficient right here, so it's 2 right here as well. So now at equilibrium, we're gonna be at x, and here it's gonna be 0.30 plus 2x at equilibrium. All right, now it's all about calculating it. And I think I'm gonna have to make some space again. Let's see. Oh, it's fine. We'll move it. All right, so we're gonna have x. Let's use this color, x. We're gonna have 0.30 plus 2x squared. Don't forget the squared. If you forget it, you're gonna get the answer wrong. Is equal to 1.7 times 10 to the power negative 5. Now, what do we do after? How do we go from here? Well, let's look at the constant, right? Where's my laser? Right here. So the constant right here is very small. It's 10 to the power negative 5. So we're gonna assume that the change is almost negligible. So which x do we change? If you're ever confused which x we change, it's always this one, the property of addition. Why? Because this cannot be 0, because if it is 0, the entire thing is 0. So we're going to assume that the change here is negligible, 0. We're going to have x 0.30 squared. Let me scroll up so you guys can see the problem. Yeah, is equal to 1.7 times 10 to the power negative 5. And then we're going to have 0.30 squared is 0.09. I'm gonna write x. And we divide. And then let's use this color. So 0.09 cancels out, and we're gonna be left with x, which is your solubility. So we're gonna plug this into our calculator, and we're gonna get our solubility. Let me see if I'm missing anything. We squared it. Yeah, wait. Yeah, okay. And you should get 1.8. If we do 2 sig figs, we'll make it 1.9 times 10 to the power negative 4 molarity. Now, let's see if our answer is correct. 1.9 times 10 to the power of negative 4. That's what we got. So this is how you solve solubility in a salt solution. Now let's erase everything and move everything back. I'll give a second for you guys to look at it. Pause the video if you need to. And we're gonna move on. Let's erase everything. Okay. Actually, let's move everything back. This is gonna take time. This might take time, yeah. Okay. We're gonna move this question back. All right, I'm gonna cross something out because there's an information on here that we don't need, and you're not gonna be provided this information on an exam. If you saw it, it's fine, but we're gonna solve it like this information was not provided. Okay, I think we have enough space. Solubility and pH effect. Calculate the solubility of magnesium hydroxide at pH equal 9, given the constant. Okay, so let's start off with writing the equation. Get to the habit of writing it, the equation, because that's how you set up your ice table. So we have, I don't want to write it here. Let's write it here. The solid, you're going to have Mg2 plus aqueous plus your 2 hydroxide aqueous minus. So this is your equation, right? Let's write our ice table. I'm gonna use neon this time. I'm gonna use I, C, E. Now, we're given the pH, right? In our equation, let me use this laser. We have an OH right here, this OH. So we have a pH of 9 and we have pOH. What is the pOH? How do we calculate the concentration of the OH ions? Because we do have OH present in the beginning. When we write our initial, right here, there's going to be some OH present. How do we calculate that? So we know that in my last video, my last two videos, pH plus pOH is equal to 14. Now, if we want to calculate the concentration of how much OH we're provided, we're going to do 14 minus 9, which is equal to 5. Now, whatever you get here, raise it to that power, the negative of that power. So it's going to be 10 to the power negative 5. That's going to be your concentration. That's like a trick I like to do. So our concentration is going to be this raised, so it's going to be 10 raised to this power, but the negative of it. That's how much OH you start with. It's important to know when you're given the pH, you have to calculate the P of OH. So in this case, it will be 10 to the power negative 5, the initial. So let's start and write that. So initially we have some amount of solid, 0 magnesium, but we have 10 to the power negative 5 concentration of OH ion. There's some change that we don't care about because it's a solid and this is some number, it doesn't matter. We're gonna gain some magnesium and we're gonna gain some hydroxide. Again, look at the coefficients. Since it's a 2 here, it's gonna be a 2 here as well. So it's gonna be x, and then it's gonna be 10 to the power negative 5 plus 2x, or vice versa. All right, now we're gonna calculate for x. So we're gonna do it here, x, 2x plus 10 to the power negative 5 is equal to, it's gonna be equal to, not this, oops. It's gonna be equal to this. Perfect. Again, this is much smaller actually from the previous question. The constant is very, very, very small, almost negligible. So we're going to assume that this is negligible as well. So x will be negligible here in this case. So we're going to have x, and we're going to have 10 to the power negative 5. It's equal to 1.8 times 10 power negative 11. We're going to divide, so we're going to have x is equal to, let me see if I'm missing anything. Wait, I am missing something. Yes, thankfully I caught on quick. It's going to be squared because there's a 2 right here. So it's going to be squared. I almost forgot. So we still did everything correct, but we could have messed up because I forgot the square here. You never, ever, ever forget the exponent. So it should be squared right here. I had a feeling I did something wrong. All right. So we're gonna do 10 to the power negative 5 squared. Let me see, make sure everything else is, yeah, everything else is correct. It's just 10 to the power negative 5 squared. And then we calculate for x, which is going to be your solubility. Let me see if I have room. I could do it on my calculator. So it's going to be 1.8 times 10 to the power negative 11 divided by, we're going to do double parentheses. Beautiful. We got x is equal to, which is your solubility, 1.8, or I'll just do a 0.18. 0.18 moles, molarity. This is your uh, solubility for a pH of 9. Let's check the answer key. Question 3, 0.18 molarity. Once again, correct. Let's see if I want to continue. Okay, we'll do one more. We'll do one more pH problem. So pause the video, try and do this on yourself. I'm gonna go straight into it. So once again, same format. We have iron and some hydroxide, solid, and it's gonna break up into Fe3 plus 3 OH minus. They're both in the aqueous. So the subscript of 3 will be moved here when you write the equation. And the charge, since it has to be neutral, we know OH is a negative charge. That means iron has to be a 3 plus charge. Type. Let's start off with our ice table, ICE. Iron hydroxide is a solid, so we will have some amount, and we really don't care about the solids. Again, we're gonna have 0. I'm gonna remove this aqueous. I'm gonna put aqueous on top, just so we have room. That's a really ugly Q. Okay. Uh, so we have 0 iron, but we have some sort of hydroxide. We are given, once again, the pH. We need to calculate the pOH. So since pH is 4, we're gonna do, let's do it up here. 14 minus 4 is equal to 10. This is our pOH. We just now raise our answer. We raise whatever we get here to 10 power to the negative of our answer. So we're gonna get 10 to the power of negative 10. That's gonna be our initial concentration of hydroxide. We're gonna gain a little bit, and we're gonna gain 3 times more than what we started with. This is basic Chem 1 stoichiometry. So we're gonna have x, and then we're gonna have 3x plus 10 to the power of negative 10. Yeah, I don't know why I picked neon green to do this question. I don't like neon green. Nonetheless, it's fine. So we gotta calculate x, which is our solubility. We're gonna have x, and I'm not gonna make the same mistake I made the last time. Remember, raise it to the coefficient. Don't forget the exponent. This is very small, much smaller, almost 3 times smaller, more than 3 times smaller than the last one. Since it's very small, we're gonna assume that This is negligible. So it's going to be x 10. Let's make it. And we're going to divide. So x will be, let me zoom out. Plug this into your calculator, and you should get your solubility, which is 6.3 times 10 to the power negative 8 moles, molarity, which is the answer right here. All right, beautiful. So this is the end of our lesson on how to calculate solubility using ice tables. Quick recap about what we went over. We talked about what solubility is and how to solve solubility using ice tables in three scenarios. Solubility in water, which is your basic solubility question, solid, solid in salt water, and solid when a pH is given. I hope you benefited from this video, and I'll see you in the next one, inshallah.